So I want to go ahead and look at the very first problem from your project together, just to give you a little bit of a head start. Make sure we're starting in the right direction. So if we read, it says we're looking at half-life. A critical concept in physics and chemistry, half-life, is the amount of time required for a quantity of radioactive isotope to fall to half of its current value. This concept has proven very useful in modern medicine and in archaeology. In this assignment, there are 5 mysterious isotopes that have been kept in a lab for different time periods. Use the information provided and the half-life formula. The half-life formula is right here. We'll talk about what each part means in a minute, to discover what these mysterious isotopes actually are and calculate when there will be 1 gram remaining. So we want to find the half-life, we want to identify the element, and we want to find when there will be 1 gram left. So if we look at the first element, it has been kept for 1.5 years. Originally there were 100 grams, and now there are 99.39 grams. So in a year and a half, it hasn't gone down very much at all, right? So if I'm thinking ahead, when I'm going to figure out how long it takes to get to 1 gram, it's going to be a really long time. I need to know my formula for half-life, right? So this formula tells me the half-life of an object, where A is the current amount, A sub 0 is the initial amount, right? The A with a little 0, we read A sub 0 to represent the amount at time 0, or the starting amount. T is the time in years, and H is the half-life in years. So what do I know in this problem? Well, this 1.5 years is my time. It's been 1.5 years. I know originally there were 100 grams, so that's my initial amount. And now there are 99.39 grams. That's my current amount. The only thing from that formula I don't know is the H, which represents my half-life. So I can use my formula, and I like, personally, it's up to you. You can leave it as 1/2 if you want. I like to change it to 0.5 because then even later when I type it in my calculator, it's easier to type in 0.5 than 1 divided by 2. And when I type in 1 divided by 2, I need to put parentheses around it because it's a fraction, but 0.5, I don't have to put parentheses. Right? So I'm going to use the values I was given to set up my equation. 99.39 equals 100 times 1/2, or 0.5, to the 1.5 divided by H. So my first goal is to find the half-life of this mystery element. We've solved quite a few equations like this by now. The opposite of multiplying by 100, if I want to get the base here by itself, would be dividing both sides by 100. Anytime I do that and I don't get an exact number, right, this time I do, it just moved the decimal place over 2 spots. But sometimes if you get a really messy number that keeps going off the end of your calculator, right, then we want to leave it as a fraction, or we want to make sure not to clear our calculator so that we don't get rounding error. And I have that equals 0.5 to the 1.5 divided by H power. Now if I convert this into log form, I have the base, the power, and equals the number. So log base 0.5 of my number, 0.9939, is my exponent, 1.5 divided by H. What's next? Well, I know that this log base 0.5 of 0.9939, that's just a number, right? I can get that in my calculator. But then what am I going to do? Right? Okay. So when I get that number in my calculator, right, I got about, and especially with this stuff, we get really small numbers. So this is where we could get a lot of rounding error. So I want to make sure I don't round until my final answer, right? But my calculator told me about 0.008827, and that's as much as my calculator told me, right? Okay, but it did keep going off the screen, so I'm just not going to actually round it at all, and I'm going to use that number when I keep going. And right now, a couple options. I like turning it into a proportion and cross multiplying. So to find h, I need to multiply across 1.5 times 1 and then divide by that third value before I get back to what h is. So really I know h is 1.5 times 1 divided by 0.008827. Okay. So again, I want that whole number stored in my calculator. Right. And when I type that in my calculator, I end up with a final answer of h is about, well, I got to 3 decimal places, which is the standard that the AP test uses for calculus for rounding things, so that's why we went with that. Right, h is about 169.926, or to the nearest whole number, I would say about 170 years. So we found that the half-life is 170 years. We can look at the table that we were given and figure out which element that must be, right? But I also want to figure out when it'll be down to 1 gram. So now I know what the half-life is, and I know the initial amount was still the same, but I want to find out when the current amount ends up being 1 gram. How many years is that going to take? So I set my expression equal to 1. So 1 gram, if I started with 100 grams, this time, I don't know how many years that's going to take, but since a year and a half didn't even go down a whole gram, I bet it's going to take quite a while, right? And I have t divided by h, where h was my half-life. We just found that that was 170 years. So I have t over 170. Now I solve this one the same way we did the last one. First, I need to divide by 100. That gives me 0.01 is 0.5 to the t over 170 power. And if I rewrite it as a logarithm, my base is the thing that has the exponent, so that's the 0.5 of 0.01 is t divided by 170. Right. If I type my logarithm into my calculator, so the log of 0.01 divided by the log of 0.5, I find that that gives me about 6.64. And for now, I'll round it to 4, but I'm going to keep it in my calculator as an exact number, is t divided by 170. And then to undo divided by 170, I would multiply by 170. So if I just hit times 170 in my calculator with the other number in there stored, right, I got 1,129.456 is t, right, is about t, which really means that 1,129.5 years from the starting point, it would reach 1 gram. So if I'm asking you, though, when is it going to reach 1 gram, and we're assuming now is a year and a half later, right? I'm going to take a year and a half away from that. So really, I'm going to say this was my t, but it tells me that there will be 1 gram left in about 1,128 years. Or instead of in about 1,128 years, we could have said there will be 1 gram left 1,128 years from now, or after 1,128 more years, right? However you want to phrase that. Okay. So this should be a good jump start for your problem. There's a couple things that weren't in this that you might run into, right? Just a reminder, scientific notation. So 6.3 times 10 to the negative 6th power means move that decimal place back 6 spots. So you can use scientific notation while you're doing the math, or you can just convert it to a decimal to do the math. Okay. And the other thing that might be a little tricky is in a couple places it says something like the amount has gone down 5%, right? If it said something like that, the initial amount I would consider to be 100%, and if it went down 5%, my current amount would be 95%. So I could use 95 and 100 as my A and A sub 0. Otherwise, you should have all of the math skills you need, right? The rest of it is just using your brain and really thinking about some of this. So if we go back quick and fill in the table from the first page. I know that the half-life we found was 170, which means when I look at this table that I was given, the mystery element for my first element must have been silicon. And when will there be 1 gram left? Right? In about 1,129 years. So that should give you a good jump start to this problem. Right? If you have questions, make sure you're asking, but otherwise you have today, tomorrow, and Friday to work on this, so 3 days to give me a reasonable best effort in terms of having this done pretty accurately. And then the year is over, and you are done with Algebra 2. So congratulations on getting this far. Finish strong with this project.